Hi guys, we're going to talk about repeated growth. And before we get into a math problem, I'm going to talk about growth in two different ways. We're going to compare what it means to grow by increasing by 2 to what it means to increase by doubling. These rules for growth are similar but not the same. They're going to have a different result. So let's imagine that we start with 1 on each side. What does it mean to increase by 2? It means that I'm going to add 2 to that side, get a total of 3. On this side, if I increase by doubling, it's going to be based on what I start with. Start with 1, and I double it by multiplying by 2. After doubling, I have 2 on the right side. Let's apply these rules again. We can see already that they don't grow by the same amount. It works differently. Increasing by 2 had a result of 3, and on the right side, we only have 2. If we apply the rule again, increasing by 2 is adding 2 to that side. Increasing by doubling means I'm going to take a look at what I start with, and I double each one of those to get a total of 4. So we compare 5 with, on the right, 4. Let's apply the rule again. Increasing by 2 is adding 2. Increasing by doubling is multiplying by 2. And if I started with 4, I'm going to add 4 more to that side to get a total of 8. Now we can see that doubling is going to grow faster than increasing by 2. This is going to be exaggerated as we move forward. If we apply the rule one more time, increasing by 2 means we're going to add 2. Increasing by doubling means we're going to multiply by 2, which takes into account what we start with. In this case, of course, doubling means we're going to get a lot more on that right side. The takeaway is that constant growth is adding, and increasing by doubling is multiplying, and when you multiply, you have to take into account what you started with. Let's apply this to a common math problem. I have a table to organize and help us think about money and the growth, like giving money to a bank and having the bank use it and give you an interest rate. I've got a table to help organize this. We can imagine that at the beginning, we'll call it year 0 because no time has passed. We start with $100. We could imagine that we give that $100 to a bank, they invest it and give us interest. Our money is going to increase. In this case, it's going to increase by 10%, which is a lot. I don't think any bank is going to offer you 10%. But what it means to increase by 10%, we know that we have to take the original 100% and add 10% to get the percent growth. In this case, increasing by 10% will mean that we have 110% of what we started with. And then we have a column here for what we end with, but let's calculate. To increase by 10% is like a problem that we've done in the past. We're going to take 110% of our $100, and we'll calculate the ending amount. This is a percent of is problem. And we have learned that when we do a percent of is, we convert the percent to a decimal. In this case, 110% as a decimal is 1.10. I can leave off the 0. You'll notice I'll leave off the 0 when I put this into a calculator. I'm going to multiply by 100. 110% of 100 translates into the math problem 1.1 times 100. Let's use a calculator to do that. 1.1 times 100 gives us 110. I've grown my money. We have $110 because we increased it by 10%. But what happens if we keep our money in the bank? We're going to apply this rule again. We have a new row. We're going to imagine 1 year has passed. The starting amount of money after that year has passed is what we ended with, $110. So the new math is taking 110% of $110. We're going to multiply 1.10 times $110. And when we do, after another year, the calculator is going to tell us 1.1 times 110 is $121. Think about our dice growing. We're not adding the same amount each time. In the previous year, we added 10 to our $100 to get 110. But notice that we didn't add 10 again. We added more. $121 is $11 more than before, because this type of growth is like doubling. We're multiplying. And when we grow, it grows by how much we had before. So we can see, if we apply this rule again, after 2 years, our new starting amount is $121. And if we're going to increase by 10% again, then we're going to be taking 110% of $121. I translate that into math. 1.10 times 121. And a calculator will help us out. 1.1 times 121 is equal to $133.10. So after 3 years, starting with $100, we increased it by 10%, but we did it 3 times. And at the end, we got $133.10. Notice that every single time that we applied the rule of increasing by 10%, we multiplied by 1.1. And if we repeatedly multiply, we could think of this growth, multiplying by 1.1 3 times, as the power of 1.1, the third power of 1.1. A quick way to figure this out is to take our original starting amount of money, $100, and multiply by 1.1 3 times. But think of that as a power, and it will result in $133.10 in the end.